We trust the physical world because we can feel it, but imagine if the water you drink could suddenly splinter into rigid, glowing wireframes. In 2003, Oxford philosopher Nick Bostrom published a paper that moved the simulation hypothesis out of science fiction and into rigorous probability. Bostrom presented a mathematical trilemma. It starts by assuming a civilization faces two highly likely scenarios. First, it goes extinct before reaching technological maturity. Or second, it survives but simply loses interest in running highly detailed simulations of its own past. If neither of those are true, we hit the third option. A technologically mature civilization would harness vast computational resources to run billions of ancestor simulations. If billions of simulated universes exist for every one biological universe, the math dictates a staggering ratio. Statistically speaking, if you pull a random mind out of that massive pool, the odds are overwhelmingly high that it belongs to a simulated observer. For 2 decades, this was an abstract thought experiment. Now, the rapid advancement of generative AI allows us to instantly render navigable, realistic digital environments from simple text prompts. Expert timelines for artificial general intelligence, or AGI, an AI that matches or exceeds human cognitive capabilities across all tasks, have shrunk from the 2040s to roughly 2030. Tech leaders like Sam Altman are aggressively pushing towards systems that can reason and generate worlds autonomously, making post-human computing a near-term engineering challenge. Astronomer David Kipping ran a Bayesian probability analysis on Bostrom's trilemma. Factoring in the observation that we currently live in a reality that has not yet spawned its own simulated universes, he calculated the odds of us living in base reality are sitting right around 50%. This is a chart showing Kipping's tipping point. If humanity ever successfully creates just one conscious simulation, that single data point violently tips the scales. The math shifts from a coin toss to a near certainty that we are not in base reality. AI progression is operating as an active countdown. We are building the exact technology required to statistically prove our own universe is an artificial construct. To look for the universe's source code, we have to zoom past the macroscopic scale and examine the subatomic fabric of physics. In quantum mechanics, particles exist in a blur of probability called superposition until they are measured. This mirrors a video game optimization technique called lazy rendering, where environments only materialize into definite states when a player is actively looking at them. Then there is quantum entanglement. Two particles can coordinate their states instantly across vast distances without sending a physical signal. In computer science, this is identical to shared memory pointers, where two distinct variables draw from the exact same underlying data address. Space-time itself appears to have a minimum resolution. The Planck length, roughly 1.6 times 10 to the negative 35 meters, acts as a strict limit where smooth space breaks down into discrete, quantifiable chunks, much like the pixels on a screen. At its lowest levels, the universe conserves resources, limits resolution, and updates variables instantaneously. It behaves precisely like an optimized computational engine. Computing requires energy. In 1961, physicist Rolf Landauer proved that erasing a single bit of information dissipates a specific minimum amount of heat. This hard thermodynamic limit defines the absolute floor for how efficiently a computer can operate. In 2025, astrophysicist Franco Vazza applied this principle to the simulation hypothesis. He calculated the raw energy required to simulate even a small portion of our physical reality down to the subatomic level. This chart compares the energy output of the Earth to what it would take to simulate it. Rendering just our planet down to the resolution of high-energy neutrinos would require power rivaling the luminosity of a quasar. Even with that extreme energy, the simulation would run millions of times slower than real time. Scientists are actively looking for the architectural edges of this processing power. Facilities like the Pierre Auger Observatory are scanning the highest energy cosmic rays for rotational symmetry breaking, a subtle deviation in how particles travel that would reveal an underlying computational grid. So far, the sky remains perfectly smooth. Physicist Stephen Wolfram describes a concept called computational irreducibility. It dictates that certain complex systems cannot be sped up or simplified with algorithmic shortcuts. To reproduce the exact behavior of our universe, you have to execute roughly as many computational steps as the universe itself takes. Simulating the universe requires a computer the size of the universe. Within our known laws of physics, an external simulation is physically impossible. If the physics of stars and particles make a simulation unworkable, the internal physics of the human brain introduces a final fatal variable: consciousness. Integrated Information Theory, or IIT, is a framework used to measure consciousness based on a system's physical causal structure. IIT challenges a core premise of the simulation argument called substrate independence, the assumption that a mind can run on a silicon microchip just as well as it runs on biological tissue. Under IIT, a purely digital simulation running on standard computer architecture might perfectly replicate human behavior, but it would have zero internal experience. It would be a philosophical zombie, acting awake but completely dark inside. Physicist Roger Penrose proposes a different biological limit with his OR theory. He suggests that human consciousness relies on non-computable quantum processes inside microscopic structures in our neurons. A traditional computer cannot physically replicate a non-computable process. If digital minds cannot truly feel or experience reality, the billions of simulated observers required to make Bostrom's math work do not actually exist. The entire probability argument collapses under the weight of genuine consciousness. We are left with two seemingly opposing truths. Physicist John Wheeler famously proposed it from bit, the idea that physical reality is built out of binary information at its lowest level. Yet the sheer energy costs and the biological nature of consciousness prove reality cannot be an artificial program running on alien hardware. In 2025, mathematicians Feisel and Krauss applied Gödel's incompleteness theorem, a proof that no mathematical system can prove all truths about itself, to the physical universe. They demonstrated that fundamental reality requires a non-algorithmic understanding that no standard computation can achieve. The universe is not a fake program trapped on a server. It is a self-generating informational entity. It processes data, conserves energy, and evolves through time, making it its own perfectly efficient, infinitely complex simulator. Discovering that reality operates on mathematical rules and discrete bits of information does not mean we are trapped in a simulation. It means we are finally learning to read the native language of the cosmos.